If you've been following what's going on in Terraform land recently, you've probably seen a ton of changes. I'm talking about fundamental changes to the philosophy of Terraform, multiple updates to the providers, and today in this video I'm going to be touching on one of my favorite new features, Terraform Actions. I'm going to be covering what Terraform Actions is, the problem that it was created to help solve, at least in my opinion, and then I'll be getting into a demo of how I integrated it into the Bedrock AgentCore Terraform Module. I'm Kevon Mayers and I'm a solutions architect. Let's hop right into it. If you're watching this video, you probably already know what Terraform is and infrastructure as code in general, but let's do a little bit of a recap. Infrastructure as code is the management of infrastructure through code instead of through manual processes. And with that, there really historically has always been a separation between what infrastructure as code should do and what it shouldn't do. But the lines are really starting to get blurred, especially with a lot of these new releases in Terraform. One of those being Terraform Actions. Again, historically with infrastructure as code, there's a clear separation point. You want to manage the infrastructure, not the application configuration, right? There's usually are going to be two separate processes, potentially two separate teams that are managing those processes. Let's take, for example, say you want to have some sort of cloud infrastructure and then applications running on that infrastructure. With Terraform or something like infrastructure as code, that's where you would deploy the actual resources in something like AWS, and then you'd have a team that would then configure those resources. So let's take it a bare bones simple example, right? You want to have some virtual machines running on EC2. You might want to have the compute actually provisioned in AWS, but then you want to deploy services or some sort of application infrastructure on top of those EC2 instances. Traditionally, those were two completely separate processes, right? In the concept or in the context of Terraform, all it cared about was, did I successfully provision the resources that are defined in my configuration files? And that's pretty much it, right? It wasn't concerned with what happens to the infrastructure in terms of what's placed on it after it was created, right? It's purely on the infrastructure itself. Now, with that comes some benefits, right? You have clear separations between who manages what, and you can have different processes for what gets changed when, but it also can cause a little bit of friction, right? Because now you have time differences between these two separate processes, right? The infrastructure has to be provisioned. Once that's then provisioned, now someone needs to have, the application configuration. If there's then a change back to the infrastructure, that might need to have another change back to the application. And you can kind of see how, these things that have been separated really can start to be blurred, and you can see some of the value of how tightly coupled these really are, right? You need the infrastructure to have the application, but the application can influence the infrastructure that you're provisioning, right? And, the traditional general sentiment messaging from HashiCorp that I've seen around this is that, there should be an intentional separation here. But in the real world, and even myself talking to tons and tons of customers with infrastructure as code and the real problems and challenges that they're solving, those lines really start to blur, and that separation can start to be a friction point. Now, there always were ways you could kind of get around this in Terraform, or at least as long as I've been using it, since about 2020, 2021, but they were always frowned upon, right? Things like provisioners in Terraform, local exec provisioners especially, they worked, but in the documentation I could find, it was always recommended against those, and those would be the last resort that you use, because again, it was getting away from that core philosophy of infrastructure as code being just infrastructure management and not getting into application configuration. Now, in terms of some of the ways you would go about that, right, I mentioned things like local exec provisioners, and effectively what that would be doing is you would be stretching the limits of what you could do with a tool like Terraform, right? You would have resources like a null resource, which effectively you could wrap, say, some scripting in it to say maybe call some CLI command while it runs and locally run some kind of, code to kind of as a sidecar that's going to be augmenting what Terraform's doing, right? So maybe in the case of EC2, You want to deploy the EC2 instance and then do some configuration of the EC2 instance in a single apply, right? You want it to be ready for anything else that might be, thrown at it. You don't necessarily want to have the infrastructure provision and then later have a separate team or a separate person then configure it. And in my opinion, that's really the core challenge that Terraform Actions was created to help solve. Those day 2 operations, right? Day 0, day 1 of kind of provisioning the infrastructure, getting things set up in general, and then day 2 actually configuring those further and using them for meaningful, tasks to solve your business challenges. So Terraform Actions is really showing that those lines are starting to blur between infrastructure management and application configuration. And it really, to me, shows that HashiCorp is listening to the community and what people are actually using and building in production. It's definitely great to see. So in this video, I'm going to be showing you how I integrated Terraform Actions into the Bedrock AgentCore Terraform module, and really how it solves a core challenge that previously would have been somewhat difficult to resolve, right? In Bedrock AgentCore, it's basically a managed offering that allows you to have more easily build AI agents on AWS. One of the components that we're going to be showing in the demo is AgentCore Runtime, which basically provides a compute platform for these AI agents to run. And with that, you need to have effectively a build, right? You need to have some bundled assets, whether that be a zip file or whether that be something like a container. And you need to have that built specifically for ARM64, right? Now, traditionally with Terraform, that's something that would have been a little bit difficult. You maybe would have had to do something, if you want to do it all in Terraform, maybe have a local exec provisioner with a null resource and some triggers and maybe some wait states and things like that to ensure that the build is complete before you continue on. But this is a pretty tightly coupled thing, right? For Bedrock AgentCore, you basically want to have and need to have the build immediately to supply to the runtime. So you really can't have a high threshold between when the build is created and when you actually want to use that to create the runtime, right? I mean, you could have it a little bit, but now you need to separately do the build and then feed that into Terraform later. But I really want to see how we could make this as seamless as possible. So that's enough about Terraform Actions and the theory and some of the historical context. Let's hop over into my IDE and we'll see how you use it in action. All right, so we're over in my IDE. Let's kind of take a lay of the land of the module, and I'll explain how I integrated Terraform Actions into it. So if you are familiar with Terraform and Terraform modules, pretty typical structure. So we have some examples. Inside examples, we have basic code runtime and then container runtime. There's also a complete one that kind of gets a little bit more complicated. We'll focus on these basic ones for right now. Without getting too much into AgentCore, basically there are 2 runtime types that you can set within the runtime component. The first is going to be code. So this is going to be sourcing directly from Amazon S3. So it's going to be a zip file containing the things like the Python file, requirements, things like that. And you also have container runtime. So that's going to be using a container image stored in Amazon ECR, Elastic Container Registry. So basically, when you would choose one versus the other, code is going to be a little bit more for your simpler workloads. I think at the time of recording, it has to be Python projects that you have there. So Python files. And there's some constraints on the specific versions of Python that you use. Container is going to be more flexible, and potentially you could integrate it with things like existing CI/CD pipelines for building and maintaining container images, and there's more flexibility in terms of you can use Node and all these other kind of things beyond JavaScript, right? So those are going to be the 2 key differences. If we look inside the module, in the example, pretty simple. Instantiate the module. We're just going to be using a local source for this quick little demo. And then you have this runtimes object, which is basically a map. So we can have multiple agents. Can drop that down and call that my agent 2 and customize and dynamically scale how many runtimes you want in their configurations. The source type is code. As I mentioned, code versus container. And then you have the code source path. So basically, where is the source code that you have for this agent that you want for this runtime for the agent? In this case, we're just directly in source. We have the entry point that we have to use for the code type, so it knows what is kind of your core Python file if you have multiple. So agent.py, we got the version, and then you can put in some environment variables. Debug is also there. This gives some helpful stuff right now. It might be expanded in the future, but as of right now, it writes a local.m file with your relevant environment variables for local testing. And then it also gives a shell script for easy Python testing post-deployment, just to make sure things are working. So you could also go on the AWS console to do that, but that is there if you want to. It's get ignored as well. So let's see, what are some of the other stuff that is in here? I think that's the majority. Let's go ahead and, I mean, you can look at the agent. All the agent really does is pretty simple. All it's effectively doing is taking a prompt and it's responding with what the prompt was as the user input. And then nothing really too much in requirements. We also have the basic container runtime. Very, very similar, as you can see. Only thing is we're changing it to be container. We're pointing to this source directory, so inside of this example here. And you see we don't need to have the code entry point because it's going to be a container, so we're building it with Docker, and it's going to be the container image in ECR. This is going to be using Strands SDK and have some tools and things of that sort, so definitely going to be some helpful stuff there. But with that being said, let's go ahead and deploy the basic example for code. We might do container, not sure. Again, those are really going to be two similar ones. But to kind of recap what's going to happen when I deploy this is it's going to bundle up using the archive file, the source directory into a zip file. It's going to upload that to S3. The module by default is going to create an S3 bucket, or you can supply your own. And then AgentCore runtime is going to then use that specific zip file for the runtime. And this is exactly why Terraform Actions is key, because we want to make sure that we build, because you have to build for ARM64 to use with AgentCore runtime. We want to build that and then package up all the dependencies and things of that sort. But we want to ensure that Terraform pauses while that happens before we actually try to provision the AgentCore runtime, right? Because we want to make sure right now, right? Say if we just upload these files to S3, and then we have it consumed directly from S3, it's going to fail, right? Because this isn't built for ARM64, right? These are just the underlying files that we need, right? You could use something like Docker, depending on whatever your architecture is, and build for ARM64. But now that's another dependency, and historically might have been what you had to do to achieve a module like this is have like a local exec provisioner, have Docker as a dependency that has to be running when you run Terraform apply. But Actions really helps extract away a lot of this, and I'll touch on some of the other ways that you would have solved for this in the past, and how you can change that now and really do it in a lot more robust and scalable way with Terraform Actions. So with that being said, I'm going to make sure I'm in the root of the directory. If you're following along and just clone the repo, just make sure you're going to cd into examples and basic code runtime, and we'll give it a ls, and we will do a Terraform init. I have an alias because I am not lazy, I'm efficient, and I don't want to waste time typing CLI commands over and over again. Okay, continuing on, initialize was fine. We are going to do a Terraform plan. I'm already authenticated into one of my AWS accounts, I believe. And cool, we got 19 resources to add and 1 action to invoke. So let's kick this off with the Terraform apply auto approve, and then we will watch the output, and then we'll validate in the AWS console, management console, on what's going on. So you can see it's creating some things here that I'm not too concerned with in terms of like the dependency, but now you can see the core thing here. The AWS CodeBuild start build is being created, and you can see it's giving us a output, right? So starting code build project build. And then it says waiting for completion, and then in progress. So this is going to be a synchronous action, right? It's going to wait and track the state of what's happening with this action and let us know if it's completed or failed. So it's going to be polling from code build to determine if the build is in progress, or kind of effectively what the ultimate status is. So you can see here, it's going through and it's creating some other things that, because there's still this parallelism in this, as in it can be running the action and also doing other things that aren't related to the action. So it looks like what it's going through is creating a lifecycle configuration. The action is also still running, because these aren't dependent resources or dependent operations that are happening right now. So we'll give this a little bit more time and we will wait, and ultimately what we're going to want to see is a green status message, and it's basically going to give us a success that the action has completed. Once the action is completed, then it's going to continue on and use the asset that was created for the AgentCore runtime. And you see we got that completed successfully, then a success message that the action was complete. Now what's happening is there's a Terraform data resource for a build trigger. The naming could be probably updated a little bit, but we'll explain what this actually does. We have that Terraform data, and then we finally have, now it's creating the runtime. And keep in mind, right, we have guaranteed that the artifact is going to be there, because if the build failed, then Terraform apply would fail, right? Because we wouldn't have gotten a success message from CodeBuild. And we also know that it is completed successfully, so now it'll be able to fetch the relevant asset for actually going ahead and creating that AgentCore runtime. And now it's going through, there's a couple other things that are there, local file for some local testing that I touched on. There's also going to be a .env file that is created with the environment variables. And finally, we got a success message, right? So apply was complete, 19 resources were added, and 1 action was invoked. Let's hop over to the management console and make sure that that is all good to go. Cool. So in the AWS Management Console, we'll start at S3 first, because that's kind of going to be the main entry point into this. And we have a bucket called AgentCore, my agent code. And there's 2 key files, right? So we have source input.zip. This is going to be basically the bundled files that come from this source. So I'm using archive file to create a zip, uploading that to S3. And then what's happening in CodeBuild is it's basically going to be taking that, building it for ARM64, and then writing it back to S3 with this different file name. Now, let's think about how you would achieve that without Terraform Actions. And I have a great example, an older Terraform module that we designed, and this was for Streamlit applications. If you're not familiar with Streamlit, it's basically a Python framework for building full stack web applications. Really helpful if you're doing for things in terms of ML and genai, which primarily are going to be pretty Python heavy. And it just makes it easier for kind of, that kind of core application logic, and then, the things like the UI and things of that sort. But effectively a similar type of workflow, right? We would have a zip file that bundles up the assets, upload that to S3. But in this scenario, what would happen is now we have Amazon Event Bridge that's listening for events of the object being uploaded. When that happens, invoke the code pipeline to run. That's going to fetch the assets and put it in a code pipeline artifacts bucket. That's then going to be used by CodeBuild, which will build based off of whatever's in the build spec, upload that to Amazon Elastic Container registry for the specific repository that we have. And then finally, the service is going to be deployed on ECS using that container image and the specific tag. And we also had some logic in here for creating CloudFront invalidation, which is a pretty common thing. Basically, without, again, going too much into the AWS service stuff, just since we're touching on it, with CloudFront, it's basically going to be caching things on edge locations. And when you create an invalidation is basically, or the reason you would create an invalidation is when you update your source code for the application, and you want to ensure that the cache is then updated so people aren't getting old content, right? That's something that you also would have to kind of deal with, either do that manually outside of Terraform, or some ways that you kind of handle managing these things in Terraform are with a null resource and a local exec provisioner. The local exec provisioner would then run CLI commands effectively, right? So like I mentioned with Docker, and things like that for building container images. You could, if you didn't want to use CodeBuild, have it use the Docker CLI and build the image and then push that to S3. But then it really starts to get complex, especially when you're dealing with race conditions and really when things are happening outside of what Terraform is aware of, right? Because Terraform is running on a local machine, right? Local machine if you're running the commands yourself, a CI, a container, something if you're running in a pipeline, but separate from the control plane of AWS. So, then it starts to get into some race conditions depending on what you're doing of, hey, is this resource here or not? And then you can run into scenarios where you start to have wait states of looping through and checking using the CLI to see if is a file present or not, or what is the state of something. And it really adds a lot of complexity. It can be fragile, right? Some things are, not going to take exactly the same amount of time every time you try to do that operation. That can lead into longer Terraform apply runs because now you're just increasing to cover the absolute maximum when it can be done a lot sooner. And depending on how you have a retry logic, you can kind of mitigate that a little bit, but it's a little bit more fragile, right? Terraform Actions helps solve this a lot more. So like I mentioned, in this scenario, the benefit is we don't actually have event bridge at all in this scenario, right? When this source file is uploaded, we have Terraform Actions is going to basically run and effectively just look for this file. And we'll look into the code and the events in Terraform Action to show how we have this kind of event-driven flow. But effectively, right, we're able to get the same logic of this without having to use event bridge, which is a huge plus. So if we kind of take a look, let's look into CodeBuild and we'll see how this all shakes out. So inside of CodeBuild, there should be one project. And in this project, if we go into project details, you can see we have a source provider of Amazon S3. So it's connected to that S3 bucket. And it's pretty simple. All we're doing is installing and basically building for an ARM64 architecture. And then we're zipping that to S3 with that new file name. So that's how we have the source input that's coming from Terraform uploaded. And then from CodeBuild, it's going to be source.zip, right? And then this is what's going to be used for by AgentCore runtime to actually run the specific code. Cool. Let's validate that. If we go into runtime, we do have a runtime that is ready. And you can also test it here in this agent sandbox. So I'm just going to put in a simple message like, hello from Kevon. All right. Whatever. I don't want the syntax warning, so I'm just going to put exclamation point. And all this is going to do is just give me the output of what I said. But it is working. It is functioning. It is deployed. Cool. Let's hop back into VS Code and see how this is actually working. So if we flip back over, let's peel back the layers a little bit. So the first thing that we want to look at is the action itself. So the only action we have in this module right now is CodeBuild. So if we kind of bring this down a little bit, let's actually start at the top. So we have two CodeBuild projects. One is going to be for how we want to build for the container, and the other one is how we want to build for the specific code, because they need to be different, right? One is going to have a Docker file and one is not going to have a Docker file. Let's continue down and let's look for the actual action. So if we scroll down more, we will see the action here, right? So we have the action, AWS CodeBuild start build. And we're basically we're using a for each and a for loop within that to basically look for in those objects that we have defined in our main.tf, right? Remember, we could have multiple agents, multiple runtimes called, whatever, and we're basically using the key for naming. We'll go back over to CodeBuild. Basically, we're looping through that and we're checking for ones that have for this specific action here, have a type of code. And also the source path is not null. So basically, are you actually pointing to a directory, right? Is this not empty? Because if not, then what are we building, right? It would fail. There's nothing that it could actually look to use for the actual build. So that's the action itself. And then there's a configuration. You can set a timeout for how long, an action should continue to run before it would actually time out. And then we have this link here for this actual code build project, right? So we define the project ahead of it. Then we have the action that's referencing the project itself, the code build project itself. Then finally, we need some kind of way to trigger the action. Now, I believe there is a trigger flag in the CLI and the more recent versions of Terraform, where during a run of Terraform apply, like in the actual command line, you can invoke an action. I'll put a link to some Terraform docs for more information on that. But in this scenario, and where I feel like most users are going to want is to actually have this in the HCL code and the way that your modules are being designed. So we have the code build project, we have the action. To invoke the action, you basically can use any resource that has a lifecycle block within it. So effectively, right, and the reason that you'd want to use Terraform data, and if you haven't used Terraform data before, resource, it's basically pretty much a drop-in replacement for the null resource, but some nice enhancements on top of it. And the way I think of it, I mean, maybe placeholder isn't the right word, but I'll just use it. Placeholder to allow you to have some sort of logic and explicitly set dependency orders to ensure that things are created when you want them to be created. So let's touch on how we're using this, right? So we're basically inside lifecycle. We have this action trigger, and then within action trigger, these are the two key things. We have events, and then we have actions, right? So this is the actions is where we reference the specific action that we want this to apply to. And then we have events. I believe there's 5, and again, I'll link to the Terraform docs, but I believe they're before create, before update, after create, after update, and then before delete. So basically the key parts of the Terraform resource lifecycle that you'd care about, right? These are really, really important in terms of ensuring you have the functionality that you anticipate. Because before create and before update, what that means is that the Terraform action is going to run before Terraform attempts to create this resource. And that's really important, and it's synchronous, so it's going to run this before it tries to create this resource. It's going to run that action, and then it's going to wait, because the action is synchronous, before it completes, before it then tries to create the resource itself, right? And the reason that you want to do it like this with a separate resource instead of doing it, directly within reason for this scenario, the reason that we did it with this separate resource is because we can set an explicit dependency to wait for that AgentCore runtime until we know the build is done. So if we go to main.tf, we actually see this here, right? We have a AgentCore runtime. And if you look, we have this depends on for the Terraform data build trigger. So basically what this means is that AgentCore runtime is not going to try to be provisioned via Terraform until this Terraform data resource has been created. And the Terraform data resource isn't going to be created until this action was completed successfully, which is synchronous. So that is the missing link that we need to allow for a single Terraform apply to take this local file, upload it to S3, build it, and then store it in either S3 with the other object type, or in the case of the one for the container, store it in ECR to use with AgentCore runtime. And that's really, what we need for this. And you can see we have the input is tracking the MD5, so basically the hash. So if we went in here and then we change, so we'll make a simple change to the agent. I'm just going to add a little smiley face to the end of this. I'll save that. And if I do a Terraform plan, it's going to detect that the hash of these contents have changed, and that would trigger a rerun of Terraform. So you can see 2 are going to be changed. 1 action is going to be invoked. So I can just do Terraform apply auto approve again. And then it's going to do the same thing, right? S3 versioning is on for the bucket. So it's going to create a new version of that object. And then that new version is going to be used to trigger a new build. And then that new build, that output of it is going to be used for a new version of the runtime. So this is giving us that full create, an update lifecycle. Now, while that's running, let's take a quick look back at the, we'll go back to CodeBuild. Now, what do you think would happen if these events were not this? If these were, say, after create and after update? Pause for a little bit and think through, put it in the comments what you think is going to happen. Now, what is going to happen in that scenario is it's going to actually create this resource before it runs the action, and that is actually introducing that exact race condition that we want it to avoid with Terraform Actions, right? Because effectively, if we tell this, hey, Terraform Actions, I don't want you to run until after this resource is created, but in main.tf, we're saying, if we scroll back down, that don't create this runtime until this data source, this Terraform data resource has been created, then what that's going to mean is that it can potentially, and oftentimes will try to create the runtime before the resource is actually done and the code build project has completed and built the assets that we need. Right, so these are really, really important to ensure that you're thinking this through and understanding the impact. I actually I submitted a PR, and it's you know, it's in the latest version of the provider, the AWS provider for Terraform, with some clarity around this, right? Because this is something that tripped me up a little bit the first time I was dealing with actions, is these specific events, but it's really, really important to make sure you understand this, right? In these specific types of workloads where it's synchronous and you want to have this kind of dependency link stuff, more than likely before create and before update is what you're going to be looking for. But again, I believe there's 5 that you have to use, but just make sure you really understand the event type that you're setting, and then also the dependency that you set for any downstream resources. Now, we could go ahead and, you know, deploy the other example, but as I mentioned, it's effectively the same flow. The only difference is that instead of rewriting to Amazon S3 with a different object name, it's going to be pushing to Amazon ECR for that container image to be used with AgentCore runtime. But that's how Terraform Actions works in this scenario, right? And that is how we are using it to solve some challenges and really unlock a lot of helpful functionality in the Bedrock AgentCore Terraform module. All right, so that does it for today's video. This was an overview of Terraform Actions and a practical example of how it's integrated in the Bedrock AgentCore Terraform module. I don't know about you, but I'm definitely so pumped about Terraform Actions. There's so many modules I've built over the years that this would have saved me a ton of trouble and been a lot more reliable and easier to maintain. And I'm going through and actually starting to, you know, modernize some of those modules. Let me know what you think though, right? In the comments down below, let me know how you feel about Terraform Actions. Do you see yourself starting to use this more? Are there any features that you think you might want added to it? Definitely want to have a lively discussion. If you found this video helpful, please like, comment, and share this video with others you think also might get some value, and subscribe if you want to see more content like this. That's all for now. Peace.